All right, so we're going to time travel back to grade 10 when we spent all our money on Robux to get VIP and Dress to Impress. And we'll FOIL this out. Way too early to do that multiplication in my head, so I won't even try. So we're just expanding this out. So 526.5 plus 40.5n. This is risky. Minus 26n. I'm sure you guys will pipe up if I make a mistake. And then minus 2 times n squared. And then I'll collect like terms and maybe put things in order from highest degree to lowest. So minus 2n squared plus 14.5n plus 526.5. And so if you were in grade 10, what you would do, because we're looking to maximize revenue, so your grade 10 teacher would be like, well, if you're looking to maximize something and it's a quadratic function, then really what you're looking for is the vert. Okay, we'll just use deep purple. So really what you're looking for is the vertex. So basically what we have here is we have a revenue in terms of n, which is the number of times we're increasing the price, and the goal is to find the vertex. So in grade 10, you guys had several strategies for doing that. Can I ask you guys, did you guys learn the shortcut for finding the axis of symmetry? I'm pretty sure you guys did negative b over 2a. Do you guys remember that formula for the axis of symmetry? I see a couple nods there. Don't copy this down. So in the quadratic formula, which is, of course, everybody has that memorized, negative b plus or minus the square root of b squared minus 4ac all over 2a. If you think about the quadratic formula, the way it's structured, to get your two x-intercepts, you're taking negative b over 2a and you're adding something, and then you're taking negative 2b over 2a and you're subtracting the same thing. That means halfway between the x-intercepts, which is the axis of symmetry, will be negative b over 2a. So it's like a shortcut for finding the axis of symmetry. Today you learned. And the neat thing is it also works if there aren't any x-intercepts too. Anyway, let's put a pin in that. That's grade 10U. You also might have the way you got, don't copy this down either, because nobody likes doing this. But like maybe you learn it this way: to find the vertex, you have to do some partial factoring. So you take out negative 2 from the first two things, 7.25n, and then you have to add and subtract. Did you guys remember doing that method? Okay, nobody likes doing that method. So we don't want to use grade 10 stuff. Let's talk about how we can use calculus. Framing this question in terms of the derivative, if we're interested in finding the vertex, well, there's a special property of the vertex that involves a derivative. If you think about it in terms of slopes of tangent lines, what's the slope of the tangent line at that vertex at the maximum of that quadratic function? The slope of the tangent line would be 0. And slope of the tangent line is derivative. So you guys know how to find derivatives. And if we can find when the derivative is 0, we can find the vertex and what that ideal price of charge is. So let's do the calculus way, and then I'll come back to the grade 10 way in a second to verify our answer. So the calculus way, and you guys now have the tools to find the derivative quickly and efficiently. So the derivative of our revenue function, we just bring down the 2, multiply it by negative 2, negative 4n. And then the derivative of 14.5n is just 14.5. And then the derivative of 526.5 is 0. So that's the derivative. And we'll just set that equal to 0. And that's just a linear equation to solve for 0. No big deal. So we'll move over the move over the 14.5. Why can't I write 4? Minus 4n equals minus 14.5. And so we quickly get the number of price increases that give the optimal revenue. 14.5 divided by 4. I should be able to do that in my head. 3.625. Do you guys get that as well? 3.625. So what this is saying is that you increase the price by 50 cents, 3.625 times, and that will give you the optimal price for, in this case, it was a round of mini golf. And if you were constrained to doing it 3 times or 4 times, you would just pick the one that gives you the best revenue. Now, if you were back in grade 10, you would find the axis of symmetry using the axis of symmetry formula. And you can see we get negative 14.5 divided by 2 times negative 2. Negative 14.5 divided by 4, 3.625. So you get the same answer both ways. But the calculus way is going to help us to do a lot more complex, like optimization problems like these. So yeah, grade 10U could just find the vertex, but we're going to be looking at way more functions of just parabolas. So we'll be using kind of similar ideas. So I thought that would be an interesting warm-up. It gets you guys doing a derivative, talks about, connects some stuff you guys did in grade 10. So what would what would the ideal price be? So it's $6.50, and then we're increasing the price by 0.5, 3.625 times. So to the nearest cents, I got like $8.31 would be like the optimal price to charge. I might lose a few customers, but I make it up in how much I'm charging per round. All right. So that was enjoyable. Anything you guys want to chat about? Kind of our first application of calculus. We can use it to do optimization problems. Did you know that would grade 10 you be able to like find derivatives from first principles? No. Think about the people in your grade 10. I shudder to think of the people in my grade 11 class right now doing derivatives. Okay, but like this isn't. I'll push back on that. Like I could tell a grade 10 person, oh, just bring this 2 down and multiply, and then just take the 14.5. But you'd have absolutely no why. It's just it would be all hand wavy magic. Teaching them the derivative would be not feasible. Okay, what we're doing today, we are doing more with derivatives. I'm going to pass this around to you guys. We'll warm up with finding a few more derivatives using our rules from yesterday. We're no longer using first principles. And then we'll just do a few more types of problems together. Really not a ton of like new concepts today. Just getting used to finding derivatives. Lots of time to practice. Did I forget anyone? I have a lot left. More than I needed. Okay, yeah, so if you guys would, here is 5 functions that after yesterday, you guys are equipped to find the derivative of using our new rules. So give them a go. You guys, I forgot you guys, or I didn't give one to you, Toby. I gave you a warm-up. Okay. I thought I had. One, two. Oh, just one. I can take that. Sorry about that. Yeah, so you guys get going, and I'll just play catch up every minute or so. I'll make sure you guys have a chance to try each one. I'll play catch up with one here. I'll use Leibniz notation just to mix things up. As we talked about yesterday, for a polynomial like that, go right to the answer if you want. If you need to show an extra step, like we're taking 6 and the derivative of x7 is 7x to the power 6. If you need to show that extra step, then please do. If you feel more comfortable writing out subtract 0 because the derivative of 12 is 0, you can do that as well. But I think that if not all, many of you guys will just go right to the derivative for at least for something like part A. 42x to the power 6 minus 20x cubed. I couldn't imagine trying to do that one from first principles. That would be really messy. I'll wait another minute to talk about B and C, but the idea we learned yesterday is we have to write those as powers of x in order to use our new rule. If you're watching at home, you can just fast forward to the parts you need. All right, I'm going to play some catch up here. So for B, we saw that we can take derivatives of rational functions by writing them as a power of x. 1 over x squared is equivalent to x to the power of minus 2. And when we rewrite the function in B that way, it's not too bad to find the derivative. Bring down the negative 2. Negative 2 times 3 over 4 is negative 6 over 4. And subtract 1 off the exponent. And that's the derivative. You won't see that in your answers or the solutions manual. You'd see 6 over 4 reduced to minus 3 over 2. And you would see x to the power of minus 3. You would see that as with an x to the power of 3 in the bottom as positive. And then for C, so you would use your exponent rules you learned in grade 11. The fourth root means your exponent would be over 4. And the x to the power of 3 means it would be x to the power of 3 over 4. So that's from your grade 11 course. We need to have those in our toolbox at this point in our math careers. But now you can find the derivative. I'll use prime notation. Bring down 3 over 4. Take 1 off the exponent. 3 over 4 minus 1 is negative 1 over 4. And that's the derivative. We will clean it up a tad. We don't like negative exponents, so you can write that on the bottom as 4 to the power, x to the power of 1 over 4. To me, that's fine. Usually, if your question is given as a radical and like a set of textbook questions, the solutions will have the answer as a radical, and x to the power of 1 over 4 is the fourth root of x. So that would be 3 over 4 times the fourth root of x. I would take the second last line there myself. But I definitely would require you guys to write it in terms of positive powers. You guys okay with those three? All right. D and E are not ready for you guys to find the derivative of, at least with our current skill set. You need to somehow manipulate those into something like part A, where you have a polynomial with a bunch of powers of x, and you can find the derivative that way. So I'll leave you to the expanding and simplifying in D, and then in E, the dividing all those monomials together. And again, I'll wait a second and play catch up in a moment. It is 3 over 4 times the fourth root of x. Enhance, 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 enhance. Yeah, 4 times the fourth root of x. Dehance, 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 dehance. There we go. Now I'm just going to open this guy up in a different tab because I'm paranoid it's not recording this tab. So we're going to do this. We're going to open recent. Okay. All right, we got a little exercise in expanding to do. Just got to get down to it, I guess. I'm doing this with my grade 11s right now. It's a split class. So the 3M kids only have to multiply binomials together, like with quadratic functions. The 3U kids have to do stuff like this, and they're upset. They want to know why. And it's like, well, because you just will need it in calculus. Just you have to trust me. Because here we are. So what do we get? We get 2x squared. We got lots of time, so I'll show all my work. Minus 3x plus 2x minus 3. And then we'll collect those like terms. 2x squared minus x minus 3. And then we got to apply the distributive law again, but instead of double rainbows, we've got triple rainbows. 6 multiplications to do. But we're just applying our knowledge of the distributive law. Eventually, we'll get it to a point where we can just take the derivative. So what do we get? I'm going to show all my steps. If you can shave off a step, that's good. Good for you. So we get 2x cubed minus x squared minus 3x minus 4x squared plus 2x plus 6. I think that's good. And then I'll collect my like terms. I think I have minus 5x squared minus 3 and 2 minus 1. I think that's how it would expand. And then finally, the derivative is the easy part. At least now that we have our really fast and efficient rules. F prime x would equal to 6x squared minus 10x minus 1. I'm going to do that just in one step. I think most of you guys are there. How'd I do? Did I make an expanding mistake you guys didn't tell me about? I see. I think we're okay. Not tomorrow. In 2 days' time, I'll actually show you guys a rule that you could use to take the derivative of the product of 3 or more functions. Tomorrow, I'll show you guys a rule where you can find the derivative of the product of 2 functions. That's for tomorrow. For today, we're stuck doing that. Okay, let's wrap this up. For E, we have to clean this up a little bit. I'm just going to divide every term by 6x cubed. I showed yesterday, I did an extra step where I showed we're dividing each individual thing by 6x cubed. So the y of what I'm doing here is in our note from yesterday, but we can just do the dividing. 2x squared minus 3x. And then the last one, x squared divided by x cubed. I'm going to write that as, it would be 2 minus 3, it'd be x to the power of minus 1. I'm writing it that way so that I can find its derivative. Block off some space here. And now we'll find the derivative. 4x minus 3, bring down the minus 1. and then subtract 1 off the exponent. 4x minus 3 minus x to the power of minus 2, which is correct. That's the derivative, but we should be in the habit of just writing things with positive exponents. So that would be minus 1 over x squared would be the derivative there. So hopefully you guys did some practice. All of those functions should be things you're comfortable finding the derivatives of using our new rules. So that could a little bit of a self-check-in for you today to see if there's more things you need to work on. Anything you guys want to chat about? All right. We're not really learning any new content today. We're just doing some different types of problems that involve the derivative. So it's all things you are already equipped to do. For example, in this next example, we're going to find not just the slope of a tangent line to a function at a point, we're actually going to find out the equation of that tangent line, which is something we haven't done yet together, but you guys have the skills to do so. So first of all, what point are we dealing with? It's x equals -1. From the graph, we can see it's -1, -6, but I'm nice and I usually provide graphs. If you didn't have a graph, then you guys would just find the y value the way you've been doing it forever. Plug x equals 1, x equals -1 into the function, and it should give us -6. So let's just do that. Please give -6. Does it give -6? -4 minus 5 plus 3. Yes, it gives you -6. So graph was provided, but if you didn't have a graph, you guys okay, you could find the y value. So that's our kind of our point of tangency. Now, I can already just eyeball and just predict what I should get. The tangent line, I'm not going to draw it yet, but the tangent line should have positive slope. And it looks like if I were to eyeball, the y-intercept is going to be around 0 somewhere. Would you guys agree? Yeah. Somewhere around there. I don't know. So let's find the equation of the tangent line, and then we'll graph it and use our graph just to make sure the answer makes sense. So to get the equation of the tangent line, we need the slope of the tangent line. And to get the slope of the tangent line, we need the derivative. So honestly, for, I don't know, like most of the next month and a half, most of our questions will start off with find the derivative of the function we're working with. So let's do that. And I hope you guys are okay if I go right to the derivative. We've done a lot of these at this point. Bring down the 3, 4 times 4, 12x squared. 2 times 3 is 6, 6x, and then the derivative of 5 is 0. So that's our derivative. To get the slope of our tangent line, we're going to evaluate the derivative, f prime, at -1. So the slope of our tangent line is the derivative evaluated at -1. Not the function. Plugging into the function gives you the y value. You want the slope of the tangent line, you plug into the derivative, f prime at -1. So what's that equal to? Yeah, it's equal to 6. I'll just show my work here. Yeah, so 12 minus 6. All right, and then we're going to pretend that we're back in grade 9, finding the equation of a tangent line. So the equation of a line, y equals mx plus b. Plug in your slope, which we found to be 6. And then back in grade 9, in grade 10, your strategy for finding the y-intercept was to plug in the point you have, which we found earlier to be -1, -6. So y is -6 when x is equal to -1. And if we solve that equation for b, we'll have the equation and it should match up with our graph. So we get -6 equals -6 plus b. I should change this question up because I really struggle making my b's not look like a 6. So this isn't the question for me. B, there you go. But we end up getting b is equal to 0, right? Kind of what we thought it would happen, but we've shown it, we've proven it. So our equation, y equals 6x is the equation of our tangent line. And let's just graph that tangent line from -1, -6, or y-intercept of 0. That has a slope of 6. I can add one more point on there. and I have the luxury of a straight line tool somewhere. Insert line. You guys can just do your best impression of a straight line. But yeah, everything seems to fit. Life is good. If you guys are doing something like this at home, doing practice, you didn't have a graph of the original function, you could use Desmos. You could plot the function in Desmos. You could plot your tangent line in Desmos, and you should see the same thing as our visual here. Nothing new in that question, just tying some things together. Are you guys okay with what we did there? Okay. All right, let's continue. All right, I think in the tail end of yesterday's problem set, you were starting to find derivatives of, under certain contexts. So here we've got a skydiver jumping out of a plane. So the skydiver is essentially a projectile. So like in grade 10, you guys would do things like, here's a projectile, find its max height, find when it lands. The new skill you guys are able to do is you'll actually be able to find rates of change for projectiles. And in situations like this, with a skydiver, the rate of change, or how fast the skydiver is falling, when you guys see how fast, you're thinking speed. That's rate of change from your grade 9 course, which equals derivative. So this is essentially saying find the derivative, plug in 4 seconds. So it's not nothing in this question is really that hard in terms of the content. It's just a new application for you guys. So h prime of t, so the derivative of 2200 is 0, and the derivative of negative 4.9 t squared, bring down the 2 times negative 4.9 is negative 9.8 times t. And that's our derivative. That gives you the speed of the skydiver at any given time. I guess technically it's the velocity for physics people, but right now we'll just worry about how fast they're going. After 4 seconds, how fast is that? H prime at 4 equals negative 9.8 times 4. I can do that negative 39.2, right? Right. And the units would be meters per second. I have a lot of space here, so I'll just write a little concluding, just to convince my teacher I know what I'm talking about. We'll just type out a concluding statement here. And then we'll just have a brief conversation for people that have taken physics about why this answer makes sense. The skydiver is falling at 39.2 meters per second. So I just said 39.2 meters per second. The negative just means that they're falling down. And if you've taken physics, or you're taking physics, this would make sense. Even the derivative should make sense, because acceleration due to gravity, about 9.8 meters per second near the Earth's surface. And what that would mean is skydiver jumps out of a plane. So every second, their speed would increase by 9.8 meters per second. So 4 seconds, their speed increases by that much 4 times, negative 39.2 meters per second. Later next week, we're going to look at higher order derivatives, like the second derivative, and make some more connections to motion in physics. But if you haven't taken physics, you'll be just fine. You guys okay that we did there? All right, again, nothing crazy in the math, just a new application there. But yeah, when you guys see words like how fast, or you guys see how is something changing, when you see those keywords, rate of change, you think derivative. All right, I think this is the last question we're going to do. This is kind of similar to the warm-up question, actually, where in the warm-up question, you had a function, and we asked, when is the slope 0? Sometimes it might be useful to find when the slope of a tangent line, or when the instantaneous rate of change is a certain number. So we're going to find on this function where the slope of the tangent is 24. And now you guys should be preconditioned It's like Pavlov's dog or something like that. When you guys see slope of tangent, you guys think derivative. It's never a bad idea in calculus just to take the derivative. You're probably going to use it. So let's do that first. We can't find the derivative just yet. We got to do a little bit of expanding and simplifying. But yeah, no big deal for this one, right? It's just x squared times x is x cubed. And x squared times 3 plus 3x. So that is our original function. Let's find the derivative. Kind of a neat. What's that? 3x squared. Yes, thank you. You guys are great. Catching my mistakes. The mistakes happen. I don't get embarrassed or flustered. I make a mistake every day, often several times a day. Some of you guys are perfectionists, and you're too worried just to try something because you're worried you'll make a mistake. Anyway, I digress. The derivative, now that I have the right function, thank you, 3x squared plus 6x. And this question is saying, when is the derivative equal to 24? When is the slope of the tangent line equal to 24? So what we have is a quadratic equation. You guys learn how to solve quadratic equations in your grade 10 course. And at this level of math, it's just like you have a quadratic equation, and you can just solve it. There's a variety of techniques you can use. I'm going to solve this one by factoring. Everything needs to be on one side. You could use the quadratic formula if you weren't sure even if you could factor it, or if factoring is not your strong suit. But I mean, I'm going to factor. We're going to have to do a lot of factoring this unit, next unit. X squared plus 2x minus 12. Sorry, minus 8. I know my multiplication tables. And then I can factor x squared plus 2x minus 8. The numbers that add to 2 multiplied to minus 8 are plus 4 and minus 2, x minus 2. So what makes this equation 0? Well, what makes x plus 4 equal to 0? We get x equals negative 4. And what makes x minus 2 equal to 0? We get x equals 2. So again, I'm just applying skills from your grade 10 math course, solving a quadratic equation. A quadratic formula would be fine, gives you the same answers. Honestly, if that is quicker than factoring for you, then you're better off just using the quadratic formula. So we have found the two, at least the x values where the slope is going to be 24. But can we just take a pause and just reflect on if this makes sense or not? This graph is kind of increasing up until this local maximum, and then it's decreasing, and then it's increasing again. So it actually makes a lot of sense that we get two spots where the slope of the tangent line is 24, right? It makes sense we got two spots. The first one is at negative 4, so somewhere about here. And the second one is at 2, so on my graph right about there. And yeah, it definitely seems like this is a fit. Slope of the tangent line, I could definitely see that being 24 at those spots. Now, technically, the question asks for the points. So let's find those points to wrap things up. If you're looking for y values, you need to use the function itself, right? So when x equals negative 4, what's the function? I forgot. X squared times x plus 3. So negative 4 squared times negative 4 plus 3. That's 16 times negative 1. Negative 16. So negative 4, negative 16 is one of our points. Put a box around it. Which seems to fit the graph perfectly. Negative 4, negative 16. Again, if you didn't have a graph provided, you could just put everything here in the Desmos and check all these answers. How about when x equals 2? Y is equal to 2 squared times 2 plus 3. That's 4 times 5. That's 20. So that would be the point 220. And does that fit? Yep, that fits well as well. 220. everything fits. Again, I know I'm repeating myself, but you guys live in a great time where you can have Desmos on your phone at your fingertips to check any answer you want to when you're practicing. You guys okay what we did there? Hopefully you would agree. Nothing really new today in terms of math, just doing some different stuff together, tying some different things together. If you guys don't have any other questions, I will stop the recording.